Hello and welcome to this world building workshop where I am going to create a map and show you how I do it. So this is the start of a series of companion videos, sort of, to my world building series, where basically I'm showing you in practice what I've been talking about in that series. So if you haven't seen the video yet where I'm talking about maps and geography and things like that in theory, then it is up here in the cards and it's down in the description, so you should check that out before you watch this one. Probably. So let's get to it. I am going to create a world, or actually I'm going to create two worlds in one. So this world is from a story that I wrote in 2015 for Nano, and the funny thing about this world, and the reason I'm using it for this series, is that it is two worlds in one. It is the same world in two different dimensions. One of the dimensions has magic, and one of them does not. So this world is going to be perfect for when I'm talking about fantasy versus science fiction and the different ways in which you world build for these different genres. That's not relevant for this video because, like I said, it is the same planet, so it's going to look the same. The map and the big things in the world is going to look the same. So what I'm going to do, like I said, it's to make the map, and I'm going to make the map of the entire world, which is not something you have to do, but I like doing it. And so I'm going to be placing out some continents and mountains and climates and, you know, the large scale stuff. The smaller scale stuff, the things that are man-made, like countries and cities and things smaller than that, is going to be a different video. So I'm starting out with this, which is the base template for a world. You've seen this shape before in maps of our own world, and the reason for these rounded edges are, of course, that the world is a sphere, and it's slightly easier to represent a 3D image in 2D with these edges, because that means that the lower and the upper parts of the world aren't going to be quite as stretched out. So I've made this to start with, and if you don't have one of these, and if you want one of these, I'm going to leave a link where you can download an A4 version of this thing, so you have something to start with. Now, first things first is to decide some basic things about the planet, and I'm going to make things very easy for myself and just say that it's basically Earth. It's the same size as Earth, and it's at the same distance from its sun, and its sun is the same kind of sun as our Earth. And the reason I'm making things so easy is because otherwise it gets really, really complicated if you start changing these kinds of things. Because then you have to change the length of the day and the length of the year, and nothing about climate that I know from our world is going to work on a world that is not at least roughly like Earth. So this is basically Earth, but a different version of it. Now, I mentioned in my other video the macaroni trick, which is a way to create continents. And so here I have a sheet of paper, and here I have some macaroni, and I'm just going to use that trick to create some continents for this world. So here we have a continent. You can't really see it probably, but it's there, and I'm now going to cut it out. There we go, one continent done. Gonna do the next one. And like I said, this planet is roughly like Earth, which means that about 70% of the planet's surface should be water. And so I can't use this entire sheet of paper because I'm using an A3 paper for my world, and so an A4 is obviously about half of that, and that is too much land. Still, I've only made two continents, and that is a lot less than 30% of this world. At least I'm pretty sure. I'm not actually measuring, but comparing this with a map of Earth, you can see that these two continents cover a lot less of the planet's surface than our continents do. So I'm making a couple of more smaller continents. let's say that's good. Now you may or may not remember why I've made these look like puzzle pieces. The reason for that is of course continental drift. It's because these continents should sort of fit together because they have all been part of one gigantic continent before, which probably looked a bit like this. So now this is what it used to look like, and we are going to split these continents up. So I'm gonna say that you moved like that, you moved over there, and you apparently brought your friend with you. Now I'm not bothering too much with the tectonic plates and how exactly these continents should have moved, because that's just too complicated for me. And hopefully no one is going to really question this. Okay, so now I have where the continents are going to be, and as you can see I moved this continent to have collided here, because I decided I wanted that to happen because this is going to be a mountain range. So let's go ahead and fill this in. And now of course the thing to remember is that while these are puzzle pieces and should sort of fit together, they can't fit exactly together, so I'm not going to just fill in right by the edges. I'm going to take some liberties. And another thing that we know is that the coast of any... I'm gonna remove you, you don't exist. Coasts are very uneven, and as far as I'm concerned, the easiest way to make that happen, to make sure that these coasts are in fact as uneven as coasts tend to be, hold the pen very far out and sort of, I don't know, tense your hand a little bit, and you'll get uneven edges. Okay, so I've got some continents now. What is next? Well, the next thing I'm going to do is to draw some mountains. And we know that there needs to be mountains around here, because this is where two of our continents collided. And that creates the mountains. And after that, mountains are supposed to be around where your tectonic plates meet. Again, I haven't really bothered to figure out where exactly my tectonic plates are, except, you know, mostly around the edges of these continents and, of course, here. So we've got some more mountains. I'm gonna say that there are some mountains going here. And then let's say we have some over here as well. And they go a bit inland because, I don't know, because I say they do. It is okay to sometimes just say, because I said so. I'm gonna start with this. I might add some mountains in later, but for now, where the mountains are, again, tectonic plates are meeting, and they're not just doing that, you know, on land or right next to land. They're also doing that in the water, and so it makes sense to sort of follow these mountains out into the water and see where could there maybe be some islands. These are probably going to be islands that were created from volcanoes, so sort of like Hawaii or Japan. So let's see. I think this mountain range sort of goes like that and out into the water around here. So I'm gonna create a few islands. And then one over here too. And the same thing could sort of be said here. This goes like that. So I think maybe, oh, okay. There's an island over here. A couple more. Okay, so now I know what the world looks like. Now it's time to figure out some climates. But in order to do that, I need to do two things first. I need to figure out wind patterns, which is actually really, really easy, and oceanic currents, which I am going to make a lot easier than they actually are, because they are not easy at all. Also, I'm going to do the climate for the entire world because I think that is a lot easier to see the whole picture than to just figure out what the climate is in your little part of the world. But if your little part of the world is the only part of the world that you ever really look at, that you ever define what it's like, then you absolutely don't have to do this whole thing, because I mean, why would you, unless you think it's fun, like I do. So first of all, wind patterns, again, they are very, very easy. Between 0 degrees and 30 degrees, both north and south, the prevailing winds are heading towards the west and towards the equator. So they're going in that direction and in that direction. From about 30 degrees to about 60 degrees, they are going towards the east and towards the poles, so in the exact opposite direction. And between 60 degrees and, well, up to 90, up to the poles, they are again going west and towards the equator. So these are again the prevailing winds. This does not mean that the wind is always coming from exactly the same direction in each part of the world, but as a general rule, most winds are heading in that direction. And if you are really interested in why that is, you're gonna have to look that up somewhere other than here, because I'm just telling you how it is and not why. There's a very simple explanation that I'm just not gonna go into because I'm not a scientist. But this is how the wind goes. Again, very, very easy. This is based on my planet being exactly like Earth, more or less exactly like Earth. Again, if you're making a world that is different from Earth, you are going to have to look into exactly why this is, because it's going to be different. And then we have the much more complicated ocean currents. I have spent hours trying to figure out exactly why the ocean currents move the way they do, and I have not really managed to figure it out beyond the basics. So in this workshop, I am going with the simplest of simplifications. So, the simplest of simplifications. Warm currents, they start at the equator, and they go clockwise in the north, and they go counterclockwise in the south. When the warm water gets closer to the equator, it gets cooler, and it starts going back down towards the equator. Again, clockwise up in the north, and counterclockwise down in the south. So basically they just go in circles. Warm, warm, gets colder, gets cold, and goes back down and joins in with a warm current again, and so on. And if the current hits a continent, it'll split in two, and one will go up and one will go down, or wherever it actually hits the continent. So what this means is that warm currents go from the equator and they go up towards the poles, and generally they are on the east side of continents. So they go like this. Or down here, they go like this. Again, east side of the continent. Cold currents, on the other hand, go from the poles down towards the equator and generally on the west side of the continent. Like so. Or like so. Now this sounds simple enough, and this is what I'm going to go with, but I'm going to say also that this is not always the case. In our world, for example, we have the Gulf Stream, which starts in the Caribbean and goes across the Atlantic and then up along the west coast of Europe, which is where there should be a cold current going down. There is instead a warm current going up. And the reason for this is because the Gulf Stream is part of a different kind of current that is not affected by winds in the way that these that I've just explained are. And don't ask me how that works. Or do ask me how that works, and I will make a video explaining it after spending even more hours doing the research, because as of right now, I have basically just given up and said that I'm gonna go with that simple version of how currents work, and yeah, that's gonna be that. We'll see, I might take some liberties and tweak it a bit and just say that this is a different kind of current, but as for right now, I'm going with the basics because ocean currents are important when it comes to climate. I'm going to start by penciling in these currents because, again, I'm not entirely certain how they're going to go, and then we'll see. Okay, let's see how this works. Here should be a warm current. It's going in that direction. There should also be a warm current going in that direction, and up here, and here, and here, I guess. And then this warm current, it goes here, continues here, and goes down as a cold current here. And this one does the same on this side, so cold current here. And this one should then go down as a cold current here, continuing here, And of course this goes down as a cold current like that. What about here? So this is another place where ocean currents get complicated, because I'm not sure about this bit. Because we've got a warm current going here, and here it splits up, like so. But it doesn't split up anywhere here, but this cold current should go here, and then back down, like that. This close to the equator, it feels weird if it could just go, you know, under. So this whole bit is a bit confusing. So this is where I'm gonna take some artistic liberty and not fill in this right now, and we'll see what kind of climate I actually want there, and if I can affect that somehow with the current. So let's move on to that. With the climates, just like with the currents, I'm going to simplify it a fair bit, and the kinds of climates that I'm talking about here, most of them have a fair few subcategories, which I am not going to bother with in this video, because that is too much for now. I kind of don't feel like I need these subcategories for every single part of the world when I'm not going to be writing about every single part of the world. So I might go into more detail about subcategories in one particular part of the world that I'm going to focus on later. So what kind of climate you have depends on the temperature and precipitation, so how much rain you get. And these things depend on your latitude, how far away you are from the equator, and it also depends on wind direction and ocean currents, which is why we now have all of those things. So again, starting from the equator, we are starting with rainforest. Rainforests exist where there is a lot of heat and a lot of rain, as you can probably hear from the name. And this is generally around the equator, low-lying areas, and normally not along the coast unless there are warm ocean currents and onshore wind, because these two things both make things warmer and wetter. And the rainforest is generally between 0 and 10 degrees, and 10 degrees is right between these two. This is the equator, this is 20 degrees. And so obviously this part of the world should be rainforest, because it's around the equator, and here on this side we have warm ocean currents and onshore wind. So it can go all the way along the coast here, at least. So that's where we have a rainforest. It's not going to be here because there are cold currents. It's not going to be here because it's too far from the equator. Then we've got these islands, where we have onshore winds and we have a warm current and no cold current here at all. So at least these here in the middle should probably be rainforest. Okay, so now I have some rainforest, and the next bit is tropical savanna. And the tropical savanna we're going to find roughly between 5 to 15 or 20 degrees, maybe sometimes a little bit further out from the equator if there are warm currents, because that raises the temperature. So let's see where we got that. Well, first of all, we got that here along this coast, I'd assume. And we're gonna have it here, and here's a warm current, so it can be extended a little bit if we want. So we've got it here, and I guess around here maybe? Yeah, let's say that. This is a little bit too far south, but we do have a warm current here, so I'm gonna put a little bit of savanna here at least. I guess that's basically it for tropical savanna, at least for now. So the next one is hot deserts. So, you know, desert, the Sahara. And you'll generally find deserts between 10 and 30 degrees. So I guess around here should be some desert. You're generally not going to find desert on the coast unless there are cold currents and or offshore winds, because the offshore winds and the cold currents are going to make things a lot drier. So we have offshore winds here, and I wasn't sure what to do about the currents here, so I'm going to make this a cold current going here, because I want a little bit of desert here. Do also have that here. Here's a cold current and offshore winds. So, desert. Okay, we've got desert, and I'm not saying I'm done with any of these yet. I might have to go and fill in a few blanks when I'm done, but for right now I'm done with the deserts. And so the next climate is humid subtropical. And this is the kind of climate that you've got in eastern China and in southeastern US. So, you know, not tropical, but still warm. And you're usually going to find this climate on the southeastern side of continents. So let's see if I have any southeastern side of continents here. So southeast, and it's usually between like 25 and 35 degrees. So we do have a prime candidate here. What else do we have? We have southeastern side here, but these are mountains. And I'm not doing mountains right now because mountains are difficult. I do not really know how they work, so I usually don't write things in mountains. So I'm sort of ignoring the mountains right now because the climate also changes apart from, you know, ocean currents and wind direction and where you are compared to the equator. It also depends on where you are compared to sea level, and that I have not had the energy to really look into. And since that's only relevant for the mountain areas, I'm, again, kind of ignoring it. But that means we're kind of, I mean, I guess I could put it here. Southeastern side, eastern side. Yeah, let's do that. But that should probably be it. It's not a lot of that. Next is the Mediterranean climate, which we recognize from the Mediterranean and also the west coast of the US. That is usually found on the west coast and usually between 30 to 45 degrees. So we've got a prime climate. So we've got a prime candidate here. Let's start with those areas. Next, we're going with the Oceanic climates, which is, in our world, Western Europe and like the southern tip of South America and Australia, also New Zealand, if you get an idea of what that climate is like. We're going to find that between 40 and 60 degrees, mostly on west coasts, and warm currents and onshore winds. Not necessarily all of these factors, I think. Either way, we've probably got it here. I'm leaving the oceanic climate like that. Again, I am going to have to go back and fill in the blanks, but for right now, I'm continuing to the last climate that I'm gonna really look at, which is continental climate. Now, continental climate, that is basically, it's Canada, it's northern and eastern Europe, and it's Russia, more or less. And you're gonna find it between 40 and 70 degrees. So it's a pretty big span and a pretty common climate. It is also a climate that has a lot of subcategories in it, which, again, not going into that right now. Just finding 40 to 70 degrees. So I now put in all of these climates, and as you can see, I have a fair few holes in my map. I expected that. I maybe didn't expect them to be this many. But what I'm going to do now is I'm going to look at a map of Earth, a map of climate zones, and I'm going to try to find roughly what places on Earth look like the places where I have my holes here, and I'm going to fill them in with what seems to make sense. I now have some climates, and I've also taken a break, and the cameras have moved around a little bit, so if the angles are different, I apologize. So the white areas up here in the north, and not really so much in the south, but up in the north, that is polar climate, so it's tundra and ice caps. So not doing a lot with those right now because they're not overly interesting for now. I did also realize that I made a mistake. Actually, I've made several mistakes, and anyone who knows anything about climate is going to tell you that. But the mistake that I do know that I made is these islands here, which I originally made Continental, but in fact they're supposed to be Oceanic. So I've fixed that, and you totally can't tell at all that something is off with those islands, right? I also added in another climate that I hadn't intended to from the beginning, and that is cold desert, which is basically, steppe. It's climates that is too dry to be anything of the other ones that I've done, apart from desert. But it's not warm enough to actually be desert. So you've got that here, for example, and there, and also down here. And the thing to point out is the reason that this part here is dry climate is because there are mountains here and the wind is coming from that direction. This is called the rain shadow effect, where basically the leeward side of the mountain is going to be very dry and the windward side is going to be very wet because the rain can't make it over the mountains. Basically, and this is again an easy concept to figure out why. Google it. I'm just not going to mention it here because it's not important why for this context, just important that this is the case. And if you haven't been making notes about why I've put which climates where, again, check out the link in the description. Apart from a template of this thing, I'm also going to include a document there explaining the very, very basics of where to put which climates and a digital copy of this map so you can see how I've implemented that. Again, though, I'm an amateur at this. This is not the perfect way to make a map. It's just a little bit more detailed and a little bit more thought through than many other fantasy maps that are out there. You might also be wondering of why I'm going through all this trouble and why should you make a map like this? And the answer is, you don't have to make a map like this. I do it because I think it's fun and because I think it informs my writing, even though I'm not going to put anything in my writing about wind patterns or ocean currents or what the climate is like all over the world, probably. I still think it informs my writing to know why the climate looks the way it does. Also, speaking of ocean currents, I'm doing more with the maps in a bit. Just, you should keep track of where your ocean currents are and how the winds go, because I'm going to reference that in coming videos, because that affects a lot more than just the climate. So, now I have made a copy of this map, which doesn't have any of the climates or anything on it, because this is where I'm going to place out some rivers and lakes. And the reason I didn't do that before was because I didn't want to accidentally put a lake somewhere where there should be desert. So as I've mentioned before, rivers run from mountains and down towards the ocean, and lakes form where there are large basins that the water can gather into. And I am only going to place out the very, very largest of the lakes and rivers. Just like I've done with the mountains, there are more mountains in the world than just these, but these are the largest mountain ranges. You can compare these mountains to like the Alps or the Himalayas or the Andes, the really, really large ones. But again, of course, there are smaller mountain ranges elsewhere in the world as well. And the same is going to be true about rivers and lakes. The lakes I'm going to place out here will be equivalent to the Caspian Sea between Europe and Asia, and Lake Victoria in Africa, the huge ones, the really, really big ones. And the rivers are equivalent to like the Nile, the Amazon River, the Mississippi River. Again, really, really big ones. Smaller ones are of course going to exist, but I'm going to get to that in a smaller area of the world. I'm not going to put out all of the tiny lakes and rivers on this map because I couldn't, it wouldn't fit. So let's get to it. And again, what I'm doing here, especially with the rivers, is going to be somewhat of a simplification because rivers don't form like a huge river in the mountains and then flow in one straight line or one not so straight line down towards the ocean. It forms as just small streams in the mountains and then they join together and become a big river that then flows. But again, I can't place out every single little stream. So what I'm going to do is simplify it a little bit. You'll see what I mean. I'm going to start here, and I need to have both of these again so I don't accidentally place a river or a lake right here, smack dab in the middle of our desert. Rivers can run through deserts, of course, but yeah, large lakes are probably not found in a desert. So let's have a river start somewhere up here, and again, this is not starting as a large river up here, it's just, yeah. And it goes a little bit like this, and whee! And ends up out there. And as you can see, this is going to go through like the rainforest and the Savannah here. And then let's have another one go from these mountains and they go in this direction, because why not? It goes like that, and as you can see, this is going to go in a little bit over the steppe, maybe even actually a teensy bit into the desert here, I don't know, but either way, that's what we'll do. And then let's find a river or two on this continent as well. I'm gonna say that one goes from over here. Whee! Whee! And there you go. So let's say we have 3 major rivers in this world, and again, just the largest ones. There are many, many more, but these are the biggest ones. So now let's find ourselves a couple of lakes. And I'm going to turn this into a lake here. It's actually a basin where the water flows, and then here it fills up until it runs out again over here. So like that. I'm just gonna have something similar happen around here. That's a lake. And I'm gonna give these people a lake as well, because they need some water. Because I'm thinking lakes don't need to be fed by like huge rivers, they can just be fed by smaller streams all converging into that spot and then running out of that lake. So these people can get a lake even though they don't have a huge mountain range that can give a huge river. That's my thinking. And I'll put it here. That's a big lake. And then I guess from that lake it should be a fairly large river running out of it. So let's make that happen. Okay, so for now I'm actually going to stop there. We have 3 major rivers and 3 major lakes. I might want to add some more later, but right now, just for the principle of the thing, this is how I've been thinking when I place them out. Now what I'm going to do, and I'm going to do this fairly quickly, I hope. So I've taken a bit of the world, I've taken this bit of the world, and printed it out. I've printed it out twice, actually. This is with the climates, and this is just plain. So this bit of land is roughly the size of Europe. It's actually a little bit larger than Europe, but more or less. And I've picked a bit that is this size because A, it's going to be good for later when I talk about countries. I'm going to pick an even smaller part of that part when I'm going to talk about cities. But there's that, and also, you know, Tolkien's Middle-earth is roughly the size of Europe, so you can't really go wrong there, can you? And now I'm just real quick gonna do the same thing to this bit that I've done to the other bit, which is some mountains and some rivers and lakes. And I'm just gonna do it real quick because you know the principle by now. So there we go. Again, these mountains are nowhere near as tall as these other mountains that I've put out on the bigger map. But the principle is the same. Here is either feeding down from the mountain, or there's a spring somewhere here that forms this lake, out of which a river flows, and same here. And here I did something that you can't see on the other map, which is 2 rivers, one coming from this lake and one coming from this mountain range, coming together to form one river here. And again, this is something that I talked about in my other video, that this is how rivers work. They flow into each other, they never ever flow out of each other, which is something that I did for so long and I'm still tempted to do, where like, no, but I want a river flowing out here as well. I'll just split this one up so it goes in both directions. That doesn't happen. Don't do that. So the next thing to consider now is, of course, the climate of this area. And as you can see, this is the climate of the area. This is continental and oceanic, and you got a little bit of other climates there. But now I need a little bit more detail. And like I said, this is roughly the size of Europe. It is also roughly on the same latitude as Europe, except of course it's on the south hemisphere because, you know, why not? And it is slightly closer to the equator than Europe is. And it also has the warm current going here, which is equivalent to the Gulf Stream that Europe has. So I think I'm safe to assume that this area should have roughly the same climate as Europe, maybe a little bit warmer, but more or less. And of course, the thing I need to take into consideration here is that Europe has a lot of oceanic climate. That is the west coast of Europe. But since this is an east coast, it won't have the oceanic climate. It has the continental and it has the subtropical climate. So, you know, I can't be blinded by Europe. I can't write, you know, British climate because that is oceanic. I can, however, write Swedish climate, which is part of the reason why I did this. Because this is somewhere where you can argue for or against writing what you know. I have written stories in many, many different climates. I don't think I've ever written anything that took place in a desert. But apart from that, I think I've used most climates. And it is, of course, easiest to write about climates that is similar to Sweden, where I live, because I grew up here, I know what it feels like, I know when I think it's a warm summer, as opposed to when someone maybe grown up in Florida thinks it's a warm summer. And so if I'm writing about someone who grew up in a climate like this, I grew up in a climate like this, I know what that's like. I have also lived in Japan, so I feel relatively comfortable writing about that kind of climate that you got in Japan, in Kyoto where I lived. But I was a stranger there. I was not used to the humidity or the heat, so I probably suffered a lot more than people who grew up in Japan did. I have also written stories that take place in a rainforest or in at least tropical climates, and I have never even been anywhere that has tropical climates, so that kind of story requires a lot of research. I do know some things about rainforests. I've done research, I have watched documentaries and things like that, but I don't know what it's like to live in those climates. I don't know when it gets too warm. I don't know what are the constant, annoyances or dangers that are in the rainforest. Are you constantly afraid of poisonous animals and insects and huge ants and spiders like I would be because they terrify me? Or is that just a thing that it exists, I rarely even see them? I don't know. So yeah, the next step that I'm not going to show here because it's kind of boring is doing that kind of research. What kind of plants do you have? What kind of animals? And what is it like to live in a climate like that? Again, if you've chosen a climate that you are familiar with, then you don't need to do a lot of research, probably. But if you've chosen something that you have no experience with, you need to do a lot of research. That's just how it is. So I hope this video so far has helped put the other video about this into some sort of context. I hope you understand a little bit more what are some things that I take into consideration when I make my maps. Again, if you thought this was very complicated and you didn't really understand or don't really remember what I was talking about, check out the link in the description because I have the basics there. And if you want more information about anything, at least those documents have the terms that you should Google in order to find out more. In the next video in this series, I'm going to talk about aliens and fantasy creatures, as well as alien and fantasy plants. So that's going to be a lot of fun. Don't forget to subscribe so you don't miss that one. If you like this video, hit the like button. If you didn't like this video, hit the dislike button. And leave a comment if you have any questions, anything you want to say, any topics that you want to suggest I do a video about regarding world building or regarding anything else. And I will see you in my next video.